and that's my Twitter handle. So today we're going to talk about memory analysis with volatility. Um, so before we start, how many people are familiar with volatility? How many people use that before for an incident response, in any incident response? Okay, few. Good, good. How many people never heard volatility before? Okay. Okay, so this is going to be the day that we're gonna hear about no volatility and also do some analysis on that. And we have some sample items here. So it's at http bit.do slash threat hunting. You will see two files. Actually, there are a lot of files, but they are belong to the previous meetups. But search for threat hunting and memory samples. Okay, these two files are going to be used during this week. So the main idea is I'm going to analyze some of the memory samples here, but there are three, and I'm going to analyze only one of them. So actually, I expect you to guys to analyze the memory samples. It's good for you because uh, after two meetups later, there will be a CTF challenge. So I'm going to upload the disk images, memory images, PCAP files, log files, all of them to, and again, a shared folder. So you're going to download and analyze that. So it's going to be a kind of, competition. So I'm going to divide people into multiple groups if possible, and then do the CTF. So if you guys analyze these samples from now, including those PCAP files and these memory files, and the next meetup we're going to analyze the disk files. Those are going to be useful for the CTF. So there will be a gift. Of course, there will be a prize at the end of the CTF too. It's not going to be too expensive, but at least it's going to be a really useful thing. And I will expect you to solve a case that I created, and the solution is not exist in the internet. It's a private CTF, so you're not going to find the solution. But everything starts with the small pieces. So this is another piece. We already analyzed a few PCAP files and also a few log files. So this time we're going to analyze some of the memory files and then continue with the disk files. So in order to analyze the memory files, we prefer to use Volatility Framework because it is one comprehensive framework, analyzes the RAM for 32-bit and 64-bit, and also it supports Linux, Mac, and Windows. So it's cross-platform. It supports a lot of disk memory images. So it's almost single pane of glass for memory analysis. And also it's open source. It's written in Python, and it's actively being developed. There are a lot of add-ons available for that. And also every year, Volatility team creates, schedules a CTF to actually a challenge contest. So expect you to create a useful plugin for Volatility Framework. So people creating a lot of good framework for that, good add-on for that. That's also good, and it can run on any operating system, almost any Windows, Linux, or Mac too. And it's still extendable, and it has an open API to develop if you are interested in developing an API. And if you know how to write in Python, you can easily create a extension for Volatility too. It's comprehensive, and it can analyze not only the RAM images but also crash dumps, hibernation files, page files, VMware memory files, VMware disk files, suspended files, all of them, even VirtualBox memory files. It can analyze all these file formats. It doesn't necessarily have to be a memory dump with a vmem executable, but it can analyze the various formats too. And it is very useful for forensic investigation, incident response, and malware focus. So we are looking for a piece of useful information, not only the structure of the memory, not only the reverse engineering point of view, but also forensic incident response and malware focus. So that's why we prefer to use Volatility. There is another tool that's called Recall. That's also a useful framework to analyze memory, but I prefer Volatility again because both it's open source, it's written in Python, it's extendable. Recall, unfortunately, it's some parts are open source, but not all of them. But you still can choose one of either. You can download from volatilityfoundation.org/releases. By the way, this presentation is available at this link, so just look for the threathunting.pdf file, so you will see all the contents here. And also, you can find the sample memory images at same location /memory-samples.zip. And if you are interested in getting more memory samples to analyze, you can visit the GitHub Foundation page to download the other memory samples. And before you analyze the memory, you need to acquire the memory. So how can we do that? There are a bunch of good tools which is created by Recall. By the way, there is no memory acquisition tool created by Volatility. It's only analysis tool. There is no acquisition tool. That's why we prefer to find another tool to acquire the memory. Recall have good tools for that. Linux, macOS, and also Windows executables, binaries, let's say, available for these tools. And if you are planning to use plugins on, let's say, if you are planning to use an operating system, it requires two things. One, an operating system, of course. Second, it requires Python. Since it's created on Python framework, you have to have at least 2.7 or 2.6 Python. But unfortunately, the Volatility is not working on Python 3 point something. But if you have a Python 3 point something in your machine, you don't necessarily install Python 2 something. Just download the Docker image, run the Docker image. That's also possible. But of course, there are some challenges. If you're running on a Docker, you have to mount the file system, access the disk images, things like that. It's up to you, to decide that. Some plugins requires extra libraries. Like, for example, if you are planning to use a Vol shell with malware plugins, it requires Distorm 3. And also, if you are planning to use a malware analysis with YaraScan, it requires Yara signatures. And of course, the core requires Python crypto. But these few of tools are, coming with the built-in. And also, the bottom one, screenshot plugin, requires pill or pillow library, Python library. So those are the requirements. So how can we use that? First of all, we need to download it from the location. I already downloaded. I put it in my directory here. Let me find it. AC console right here. Okay, I have my Volatility 2.6 Max 64 standalone. I just downloaded today. This is the latest version, latest stable version, let's say. So let's assume that you also downloaded from Volatility Foundation release page, and as usual, all you need to do is type the command and hit enter. It will show you the help, but here's the help. It requires some plugins to specify, and also image file that you have to say, and also the profile. So these two are really important in order to run that. First of all, Volatility needs to know what kind of memory image it's working on. Okay, so that's why you have to say profile is equal to something. I'm going to show all the profiles, available profiles, supported profiles by Volatility. So you have to choose one of them. The second, you have to show the image file. And the third one, what you want to do with these memory image files. You want to dump the process files, network connections, find the malwares in the memory, or the clipboard, or the screenshot, or the event logs, or the hive files. Whatever you want to do, you need to say something with the plugin section. So it's pretty simple. Plugin, image file, and profile. Some plugins requires extra parameters like directory to dump, or maybe the signature of the path and things like that. So for example, here, it's a basic usage. It says, show me the process list by using this memory image and the processors pack 1, and it's 64-bit operating system. That's that easy, and it will show you the process list. I'm going to show you a lot of examples. Don't worry about that. So you will see the real-time examples of these almost 25 examples. So don't worry about that. You're going to get used to this tool a lot. So if you are interested in getting all the help, of course, -help will be the command for that. So what are the supported profiles that needs to be specified? So these are the profiles, Windows, as you can see here. But you may say that, hey, where is, Mac OS or Linux? Those are also supported, but we usually focus on analyzing the Windows images. That's why I put only the Windows here. But of course, you can access to the all profile list. I also included that in my presentation. Mac OS, Linux, or even Android, those kind of images profiles are available at GitHub page of Volatility. So it's case sensitive, so you have to say you have to carefully type the uppercase and lowercase. Okay, and it's really selecting the service pack version because the memory schema is changing with the service pack. That's why you have to specify with the service pack. And you may say that, how the hell I can know the service pack of an operating system? You can try. You can try with one. If it doesn't work, try with the next one. And also, it has some capability to identify the image by itself. It can narrow down the scope for you. I will show that example to you. And also plugin specifications. So, for example, if you're interested in working on some plugins, you may type only the plugin here and then dash help. It will show you the help of that plugin. Okay, so there are a lot of options, but you can access to all the details by using that. And the last thing that maybe you're interested in, you can import Volatility as a Python library. That's the beauty of Python, Python and Volatility. It may just run like a library, and you can import that, and you can play around with that. That's, if you don't want to use the standalone executable, just download the Python library and use that as an import to your Python environment. Go ahead and use that. That's also possible. So the command references for various operating systems. So we're going to focus on today usually on Windows core command references, some of the GUI, and also some of the malware here. Linux and Mac, I'm not going to go into details on these sections because we have limited time here, but I'm going to show a lot of examples on Windows here. And usually malwares prefer to run on Windows. That's why we usually instant response to Windows. So these are the common core Windows command references, or let's say plugins. So for example, this one, image info, is one of the important one. It will help you to find out what kind of images this will look like. And also we're going to take a look at the process list here. And let me see, handles, and CMD scan here, consoles here, environmental variable here, even version information. We're going to take a look at some of the, let's say, maybe even Internet Explorer history. We can grab that. And also we will use proc dump to process memory. And also crash let me see. We're not going to take a look at the crash dumps here, but you can take a look at it by yourself later. And let me see, file scan. We're going to take a look at that. Connection scan, or even maybe the net scan for later operating systems. And we're going to take a look at the Hive scan to find out some of the hashes, or even the registry dump. We're going to look at it. And strings, of course, will be the important part here. Wall shell, and let me see, that has to be malware, but unfortunately I couldn't include them all. So all the references are right here, and I'm going to use exactly the same way, just like in a real incident response. So it's really hard to memorize all the plugins and what they are doing. So that's why I usually prefer to open it in a separate window and take a look at that, what kind of things that these guys are doing, and then do the examples or maybe the analysis by myself. So first of all, I will analyze one of my disk images here. Where is it? This is not, yes, this is. So let me show that first, and then I think it should be right here. Okay, yeah. This is my lab environment. So this is going to be your CTF to not the next meetup, but the other meetup. Okay. In the CTF, you will take a look at an example environment where an attacker compromised this environment. Okay. So the attack started from the outside, but we don't know how he compromised this machine and then compromised the other machine, whether or not. Okay. We don't know, but we will analyze. But for us, maybe a kind of spoiler here, we will analyze this machine, maybe this one, okay, I'm going to prefer this one actually. I'm going to analyze this one to look at its memory, and to find out what kind of connections, what kind of sessions, what kind of process exists on that. So get some ideas about this platform. So in your CTF, you will have the log files, disk images. We're going to analyze the disk images next week, next meetup. And in the CTF, you will have the log files, disk images, memory files, pcap files, all of them. And I want you to analyze the environment and find out how the attack started and then how it is expanded in the backend of the environment. So, okay, let me analyze this domain controller here. Okay, so my domain controller, it has a dc.memory here. It's just right here. And my standalone volatility is also just right here. So I'm in the same directory. I have the volatility here, and also the DC folder is right here, and the memory file is inside that. So what I'm going to do is, first, I need to know what kind of image I'm working on it. So what I'm going to do is I'm going to use my -f to specify the file, and it's going to be dc.memory here, and the plugin is going to be image info. Remember, image info will help us to identify what kind of operating system is this one. Okay, so I think that's all we need to specify for now. By the way, since this is really complicated, solution, or let's say project, it requires a little bit time to run some of the plugins. So for example, image info is one of them. It will take a couple of minutes maybe, depending on the size of the memory. If you are analyzing an 64 gigabyte of memory, it will probably take more than 10 minutes to complete to analyze the image info. But this time it's going to take probably 1 minute, and it will show us a few options what it could be. Okay, and I'm going to get the my profiles ready so I can choose from the list.
So I assume that we already see process how you retrieve them memory.
Okay. Actually, that's pretty easy, and let me actually show that. Probably there will be a lot of commands here, but I didn't show in any example on that. But it's pretty easy. Probably somebody should show here. Okay, yeah, there we go. So this is just this is the command with pmem, and this is the executable that I was talking about. It only takes one argument, name of the file. That's all. Okay, it's going to create an image file for us. But if you wanted to, what is that? Debugger, maybe an option, but it's that easy. Even for lin pmem or mac pmem or win pmem, just only the command name and also the memory name, memory image file. So here we have the couple of options. It says this could be the Windows 7 Service Pack 0 or 1, Windows 2008 Service Pack 0, 1, or maybe R2. So we have at least 6 options here, and I know that this is a domain controller, probably it's Windows Server something. Then we have this many options, right? So probably one of these, and we can try, of course, and to find out, but it is Windows Server R2 Service Pack 1. So this is the correct solution here. Actually, that is right here. So this is my image file, and this is my profile, sorry. So first of all, I'm gonna get all the processes in this image file. So let me do that first. This time I'm gonna use PS scan, process scan. Let me show that in right here too. Processes. Okay, yeah, right here. Actually, PS list also is a good one. PS list, or maybe the PS scan, or maybe the PS3. I'm gonna use two of them actually. Let me see where it is. Okay. PS list here. and minus profile is equal to, okay, and I'm going to copy the command to the end because I'm going to change it multiple times. PS list. Okay, now we have a bunch of processes here. So first of all, we need to have an idea what we are looking for. We are looking for a kind of processes that might look like an interesting process for us first. Second, we need to know what kind of processes have an interesting connection with other IP addresses, right? So maybe the external IP address, maybe the IP address that we are not expecting to have any conversation. So here's the list of the processes, but unfortunately I don't know the network communication, in this case. So by the way, it says the time is UTC 0. If you're believing that the time zone is not correct, it should be something like maybe Pacific summertime, or maybe Central summertime, whatever. You can adjust it by using the time zone. It will adjust the time for you, so you don't necessarily have to worry about that too. Okay, so by the way, at the at the very bottom of the list, you can see that vmem 1.4 is also exist here. So it actually captures itself too while capturing the memory. That's why we are looking at that. So, but we need to know who is running vmem, how it is being run. Okay, so, and I think this is the session, thread session, yes. So as you can see, this is running on session 1, and the other commands are running on session 0. What's the difference between session 1 and session 0 in Windows?
System.
Huh?
System. One's running a system.
Yes,
System. Null session.
Yeah, system is null session. That's right. And session 1 is belong to a user. So that means it's being created by a user. We know something in our mind now. But what is the parent process? We need to know. It says right here 1156. 1156 is just right here. That means it's being triggered by a command executable. And this is the command executable parent process is 3304, and it is right. Actually, that's why we have PS3 here. Let me show that. It's better to see if you wanted to see the hierarchy of processes. So because the parent process is important, we need to know who is running the memory capture. Is it being acquired illegally or legally or whatever? We need to know. So of course I created that, but we need to trace that. So vmem, as you can see here, we have 3 dots. It means that it is the child, and the parent is with 2 dots here, just 1 line above. It's cmd.exe. And in its parent process is Explorer.exe here, and the parent process of Explorer.exe is right here winlogon. Okay, this is how you can trace an executable in a memory image. So we know that it's vmem is being executed by command line, and it's being executed by Explorer.exe, and it's being executed by winlogon. So it seems legitimate here. But if we, let's say, see some processes that we wouldn't expect to see, then that means that this thing looks like an interesting connection for us. So we will come back to that point. Apparently, we don't see a lot of interesting process here. There is one Wireshark here, Google Update here. But of course, you cannot assume that if a process is just a name, it says Wireshark, it doesn't mean that it's Wireshark. We need to know that, right? We will take a look at that point. We will come to that point, but let's go over the basics now, and then we will be taking a look at all the interesting stuff here. So for example, I can take a look at all the DLLs of a process here. So let me just copy this line here. It will show me all the DLLs opened by an executable. I think this process is vmem. As you can see, it has a handle with NTDLL, WoW64, and other DLLs. So if you are dealing with a process that you are not expecting to see any kind of interesting DLL here, that would be how we can extract from the memory. So this is innocent, but I need to know what kind of files this process is being used, right? So we can extract it from the memory as well. So which process have handle to a file object, you know, and that will give us an idea if a malware, for example, if you're acquiring a memory from an infected machine, probably a malware have a handle to a file to encrypt that file. So you better know that. So how can we know that? There is a good option for that. It's just handle. Okay, this is exactly the same, but this time we're saying that handle or handles. Okay, it's gonna give me an error here. No, yeah, no such plugin. Okay, so interesting stuff here. So we have one registry here. It says type here. It says registry, and there are a couple of directories here. That's okay. But here we have a file object. It's Windows. And also we have another DLL here, another file here, file itself. Of course, a process have a handle itself too. That's okay. So we have ports here, but those are not a TCP port yet. So this one is just a key, but what we are looking for is just right here. So notice this line. It says the device hard disk volume 2 and temp directory. It says vmem 1.4 and dc.memory. So what do you think? This is the parameter of vmem, right? It's just vmem exa space dc.memory. This is how we gather the memory file. So we have the handle here. If let's say this was a malware, you will see that there is a docx file. It's been encrypted by this malware, or maybe another separate file. It's been created by this malware, and it will delete the original file. So this is how we can find the handles, and especially the file handles are important for us to take a look at that, because majority of the malwares, they're doing something on file system. So that's why we need to know that. And of course, we can get the idea how these commands are run on this machine. So another really good command that I like is commands or consolas. What was that? Consolas. Yeah. So this command shows us what kind of commands ran on this machine, and also the output of those commands. So remember, while we're typing on a command line, it just shows something on the screen, right? So it's right here. So let me go back to the very top of the my command. Where is it? Okay, it's right here. So this is my command, and this is the output. It says process conhost. It just did something. It just printed something here, but this is not what I'm looking for. But here's the interesting stuff. CMD executable, and here's the command: ping 10.131, an IP address, whatever, and then nets.exe minus ANO find 23. So these are the legal commands that's been run on this command line. As you can see, there's a typo here. Telnet, just try to quit the telnet session here. That means this thing actually open, and this can be communicated with this telnet session. And also IP config here, and ping to an host here, and also another IP config here. Here's the output. So you don't necessarily be in front of that command line here. You can see that right here. So the telnet command, as you can see here, it's not a recognized command, but it's on the screen. That means the telnet screen is connected. And IP configuration here, it says 10.131.46. This is an IP address belong to itself, apparently. And here's another IP address. It's a loopback IP address, IP version 6. And the ping command here, another IP address belong to another interface, 10.01.10. And let me see, dump pcap. It has some outputs here too. So here is an interesting one here. WinPmem, I just tried to figure out what kind of parameter it's being taken. And as you can see, I just run WinPmem space DC memory. That's that easy how you can acquire memory. And let me show you interesting stuff here. So if I scroll down here, Let me actually put it a little bit high here. So here's the interesting stuff. In the console, it's been just padding from somewhere to somewhere, and this is the progress. See that 0%, 2%, 4%, 7%, and it is only up to here. Why? Why the rest of the command console is not available on the memory? Because this is successfully acquired from the memory, right? Why can't I see the rest of the process?
Is it related to clusters or?
No. That's a simple answer, actually. It's an interesting and simple answer. So remember this thing. Yeah.
Was it just that's the point in time that the snapshot was taken?
Yes, that's right. So it's trying to take the snapshot. This vmem executable is trying to take the snapshot of the memory, and it's also doing something in the memory, right? This was the point of time it get the memory piece of that section. That's why it says only the console is available up to this point, because it just took the memory section of the console at this point, not the later point. That's why we can't see the rest of the memory. But it's okay. You know, this is the side effect of running on a live machine, because whenever you did something on that machine, it hurts the memory. That's why you have to have a stupid simple tool to take a memory snapshot of an system, so you will not create a lot of noise in the memory and also wipe out the memory. Remember, there are something in the memory that those are not available from the operating system, but we still can grab that by using volatility. So for example, some processes, those are run and died, but we still can grab them from memory. If you try to use this machine, and also if you try to pollute the memory, those are going to be disappear over the time. So that's why you have to take the memory at the very beginning of the process and do whatever you wanted to do in the rest of the time, but you still have a plain copy or a clean copy of your memory. Yes?
So is that console capture just capturing the console during the period of time that the WinPMem is active, or is it looking at historical data from before?
It's just actually taking the memory section of cmd.exe. So cmd.exe have some memory, and this thing also polluting its memory too. That's why that memory section is dynamic while it's being taken. So some sections are actually changed after this point of time. That's why it's not showing us in this point of time.
So it's not that the OS is saving or logging the console stuff, it's just that it happens to be in the memory.
Yes,
console.
yes, exactly. But you still can see the progress while you are getting the the memory. Okay, this is how we can get the what was that? Consoles here. And also another my favorite is environmental variables, because that's also important. What kind of machine we are working on? What's the name of this machine? What are the environmental variables? That's why and words like this and words yeah, that's just like this. So this is going to show us the whenever you type a subcommand in a command line, it will show you the environmental variables. Of course, we have tons of environmental variables here, but some of the important ones here, for example, the name of the machine right here also, and also command line here, maybe the number of the process, operating system, and also the sum of the paths. Those are being used by the command line. And of course, some of the specific libraries like Java, or maybe the username, or maybe the program files, and the associated file path. So for example, path text is this one, maybe important depending on the situation. So those are the things that you can grab from the environmental variables. So another one, okay, yeah. So I wanted to get a memory section of a process, right? So for example, let me come back to that point again. Yes, sir?
In this other screen there, what was the process on the left side? What is the meaning of the environment variable in relation to that process?
Sorry, where is the process?
So like Microsoft.active something, or first call, second call.
This column?
Second call.
Second column?
That, yeah.
Microsoft.
Because
Yeah, that's the process name. Oh, okay, yeah. So some process actually in Windows environment, actually it's also the same in Linux and Mac OS. every process have its own environmental variable. So you can set an environmental variable for a process. That's why every process has different. That's why that we have a long list of environmental variables here.
So those are specific to those processes?
Yes, exactly. So for example, some pieces may not be available from the other environmental variables. So for example, remember in Python, we're setting a lot of environmental variables while we're running, but those environmental variables are not available from the other processes, just available in Python environment.
Also, another question.
Mhm.
Maybe it's stupid question. I'm just curious. Can hacker use this application to make screenshot, like snapshot of RAM memory, and after
Yes.
go in it and pretty much see what you type in console, log in another machine in this way to take credentials?
Yes, that's possible. That is possible. Actually, we're going to show that from this memory we can grab the password. And you can grab. Sorry?
I think it's like a heartbleed.
Yes. Yes,
you
exactly the
command and
similar
retrieve.
mistake. Yeah, exactly. So in that case, for example, in heartbleed, the mechanism is working like this. So I'm sending you 4 bytes and you're sending me 4 bytes. And I'm saying I send you a 4 byte, right? 4 bytes. So in heartbleed, unfortunately, the developer implemented in a case that I'm sending you 4 bytes and I'm saying that I send you 64 bytes. And you believe me and say that, okay, if you send me 64 bytes, it should be in my memory right here. Let me grab the 64 bytes and send it to you. But unfortunately, I sent you only 4 bytes. The rest of the 60 byte is coming from your private memory. That's how you can grab from. And in that private memory, it might be private key, or maybe the password, or maybe the username, or maybe the cookie. That day, maybe the end of the internet. But some people really manage that process very well.
So you want to, like in a business environment, you want to monitor for this process that someone like executing. It
Yeah.
can be considered malicious intent.
Exactly.
If it's not a,
Exactly. So for example, in this case, there is a one process. It has malicious address space, but it's a legitimate process. So that's the challenge here. We're going to find it out. So I wanted to take a look at the process dump of maybe the process. So for example, let's choose something simple because I don't want to get a lot of process memory dump here. So this is the process that I wanted to use, Notepad executable, and its process ID is 3912. Okay, let's get the memory space of this process. Why I need a memory space? Because if you wanted to see a network connection, if you wanted to see some special strings, maybe the encryption key, it's a good idea to take a process memory of an executable. So for example, I believe a few versions of Kerber's ransomware and also another ransomware, they're using their memory to keep the symmetric key. So some versions they were not using the public key cryptography. They were using just a symmetric key. All you need to do is get the key. So the thing is, the developer doesn't know how to use the private section of memory and clean up the memory, all those things, and just create a bunch of strings as a encryption key and forget to delete them, wipe that area. So what we do is just take the snapshot of that piece of machine and then find its encryption key, decrypt all the files. So that's possible, and we are looking for a kind of thing in this Notepad executable. Of course, we're not going to see a lot, but this is how they process. So what we're going to do is I'm going to use the process dump here. So in this case, come on, man. Proc dump here, and in this case I need to say some folders to keep all the generated content. So I'm going to use the dump folder here. Let me clean up all these things. So I'm going to create again. Sorry about that. Okay, now we have a clean folder, and the output is going to be under dump folder. So the process of process dump of minus p, what was that? 3912. Okay. This is going to dump the memory address space of Notepad executable here. Right here we have the executable exe. Of course, do not click on that, just double click on that, just make sure that what you're looking for. If I have an executable here, I usually prefer to take a look at that in a Windows, file object. Remember, this was the very first day we show you. File command show you the true file type of an file. So it says executable, but it's supposed to be memory, and it says executable. How is this possible? Why I'm seeing an executable here instead of raw memory section? Remember, process itself was a bunch of binaries on disk image, but whenever you click on that, it is exactly the same thing on the memory. So you will look an executable file in the memory in the same way. And the best thing is now it's uncompressed. Remember last week we looked, maybe the last meetup, maybe the previous meetup, we looked for some malwares. Those are using the compression. In this case, it's uncompressed. So you can take this executable to analyze the uncompressed version of that piece of executable. So this is why it has been, it says executable, and it's really executable. And this is its memory, the binary file. And what I'm going to do is I'm going to take a look at some of the strings here, and it's going to be at most 6 characters, let's say, and dump dash executable here. So this strings command, remember, it will grab the human readable strings from this binary, and it will show us. So for example here, if I look at that, there are some Windows API function names here, and also some variable names here. Again, some Windows API function names here. So maybe we can see some of the content of this txt file. So obviously this thing is coming from the very beginning of the executable. Remember, this thing stands for backward compatibility. So this is not a Windows 16-bit application. Whenever you run a Notepad executable on a Windows 16 machine, it will prompt you this one and execute. So this is just a backward compatibility. You can understand that it's an executable here. So here is the sections of an executable, and also the library, DLL libraries, imported DLL libraries, and also some of the contents here. So if I think in this Notepad there is no content in here, but if it was, you will see the content of that text file as well. So these are all the names of the Windows API function names, and if I scroll down here, I will see some of the resource files imported by Notepad executable as well. So this is how we can find the memory dump here. Or maybe I can take a look at the Windows. Let's find another executable here so we can see some connections. So for example, I'm gonna use Google Update. This one, 2200. Sorry?
Did you want to wipe that dump directory first?
Unfortunately, this memory section is not available. Maybe that's some of the side effect if you are working on a small amount of memory. Sometimes some part of the memory is just being swapped to the page file. Remember, if the memory is not available, it just copies some of the content to the disk file. Whenever it needs, it just reads from the disk file. So that's why we have to have that copy of that section as well in order to get the Google section. Anyways, not important. Let's continue. So I'm going to take a look at the event logs here too. That's also a good one. But I think this event log is only available for Windows 2003 machine. So let me try this first. I'm going to put it in dump file. If it doesn't work, I'm going to use the Windows 2003. Okay, yeah. So let me get rid of this one. Instead, I'm going to put this one. So unfortunately, the latest version of Windows operating system doesn't allow you to export the event logs, but I believe Windows 2003 and Windows XP machines allows you to export the event logs from the memory, so you can take a look at them as well. So I will have a bunch of EVT files if everything works correctly under this folder. Okay, while it's running, I wanted to take a look at some of the. Okay, this one is good. I'm going to use this one. Before that, okay, yeah, finally. There we go. So we have the event logs here. Although it's not that clean, but at least it's readable. And here the system event logs here. It's pretty useful. If you forget to take the event logs from the machine, that's your friend. But you should definitely get the event log if you are responding to any incident, because that's the most important piece for event, incident response. Okay, anyway, so this is how we can get from event logs from a memory. So this time I will use something different. Dump files. Dump files allow you to dump some of the file contents from the memory. Remember, when you are working on some files, it's actually being copied to the memory. And whenever you say save file, it's been saved to the file. So that's why you may see some part of the files in the memory. And I'm going to copy some of them. Of course, if you run the command by itself, you will see a lot of results, which may not be useful for you in the most of the case. That's why I will only choose some of the important ones by using a regular expression. So dump files again takes a directory parameter here. It's pretty straightforward. And -r stands for regular expression. Here I have a little regular expression that says the end of the file, end of the line, sorry, should be end with txt or log. Okay, and if, by the way, it's case insensitive, so it's going to dump. And I wanted to see a summary file here. It's going to generate a file that contains a summary of these text files or the log files in that summary file too. So the important thing is not all the log files that we are aware of that. So for example, a lot of executables use their own log files. So you may forget to copy them. So for example, IES or maybe the application running inside the IES may have standalone log files. That's why we need to know them, and also we need to copy them. That's also really helpful here. And secondly, a lot of Windows services, they have txt or log files that are running behind the scene, but they're not showing it to you. That's why we also use this, simple snippet to take that part as well. And let me see how it is going. It will take some time too, probably. Yes, exactly. So on this file, you're not going to be able to find them all. But of course, in the next meetup, we're going to take a look at the disk analysis. In that case, you will find all files on disk, so it's going to complete. So you will have the PCAP, the network capture. So that means data in transit. So you will have the memory, that means data in active, and also data in stable in the disk file. So you will analyze 3 of them. So this is the summary. As you can see, DNS log files, DHCP log files here, CBS, I didn't know that, what the hell is this? And so Windows update log files here. So you can access them right here and grab them and also use them for analysis. Unfortunately, it's not a TXT file, by the way, but it is. It contains the file that you are looking for. For example, if I say strings again -n, and let's say 10 characters at least, and I will say dump star, and I want to say more here. This is the event logs. This is okay. Probably these are the yes. Definitely, these are not the logs that those are exist. So actually, I should supposed to see the name of the file here. Anyway, it's not showing that, but it's coming from some of the binary files here. So this is the log files that's being created. I don't know, maybe Windows Update Service, whatever it is. So it's just showing the content in the summary file. Remember, So we can use these files to deep and dive on our analysis. So most of the time you will probably have these files while you are doing the indication of compromise collector. But if you forget to get them, you can still get them from the memory. Actually, if you forget to get some log files, it happens all times. Okay. For example, I responded to, I don't know, maybe more than 50 times to incident response. I still forget to get some log files because I don't know whether they were open in the memory. While I was analyzing the memory, I figured out that there are some files I forget to copy them from the disk image, and I can't ask the customer, say that, hey, Mr. Customer, can you send me that log file too? Because I forget to take that. It's embarrassing. That's why I usually prefer to grab it from the memory. If I can, of course, I call the customer and I say that I need that file. I forget to get it. Okay. So this is how we can get the log files from the memory. And let's go back to the network section. This is my favorite. This is definitely my favorite because, by the way, there are multiple network-related commands in Volatility. One is netscan. It is compatible with Windows 2008, Windows 7, and also the later versions. But you can't use conscan, TCP scan, sockets, on all these network-related libraries. So let me scroll up here. So it says here, networking. It says connection, conscan, socket, sockscan. Only this one works with the later version of Windows. Okay, these are all four of these. Unfortunately, they don't work with Windows 2008 and those are later versions. So if you are working with Windows XP, Windows 2003, and earlier versions, this is your friend. These are your friends. Yes, sir.
Is the reason they don't work with the later version of Windows because that feature is not implemented, or because it isn't?
No, actually, this is just a backward compatible. They already created the latest version here. This one works. They just keep that files and use another name. That those plugins just for backward compatibility. I think we have enough in our hand, more than enough actually. NetScan, it's pretty extensive here. So as you can see here, DNS, it has a lot of connections here. By the way, it was a good idea to export this to a file and we make work on this file because it's a long file here. I need to analyze it, but unfortunately I forget to copy this to a file. Maybe you can copy that and also analyze it. Just ignore DNS.exe file here because it seems obviously not a useful candidate for us. But if I scroll up here a little bit more, where is it? Okay. So let's see what kind of other connections here. So 1, 2, 3, it's NTP, that's okay. Network time protocol here. Okay, so here's the fancy parts. This is the part that we are looking for. So it says listening, and established ones are important ones for us. So for example, here we have an established. I think it's loopback, that's okay. These are also loopback IP addresses, those are okay. But here we have established here. Okay. These are closed. These are established. There has to be another established session here, but unfortunately I couldn't find it. Okay, there must be. It must be right here. Let me see. 399 establish here. Another establish here. Where the hell is it? That close that session before the memory dump. I don't know. It's supposed to be here. Okay. Lastly, let's take a look at here. If I can't find it, I'm gonna skip this part. Close. Establish here. Establish. There we go. We finally have something in our hand here. So these are the established session. Of course, those are the important ones for us. So remember the IP address of this machine was 10.0.1.10. It has a 445. It has a connection with 1095 port or 1.100. So this port, do you think this port is an interesting port for you guys? Do you guys also agree with me? Because this is interesting for me because I understand server ports for 45, which is okay, but I don't understand why the client uses a lower IP address to connect to me. So it's supposed to be a high end of the IP address, like 10,000 or maybe the bigger than 10,000. So that's an interesting thing here. Something is going on with this client here. This just took my attention here, and I think that's all we have now here. So you will gotta include take a look at also the log files to investigate what's going on between these two clients here. Another one is Hive list here. By the way, besides Noah team, is that anybody from besides Noah? Nobody?
Patrick was out there.
Patrick is out there?
He was.
Okay. Now
A while ago.
doesn't seem to be here. Okay, there's supposed to be a pizza here, and it's almost 7:30, and that's interesting. It's supposed to be here. Okay, so let me show you a couple of more examples here. Hive list is a Windows memory, Windows registry dump here. So Hive, remember every Windows registry like Windows System, Windows Software, Windows, whatever, those are called Hive. And these are the registry files. So if you have this one and these two guys, you can actually decrypt the whole SAM database here because you have the same Hive key inside Windows, the security, and also you have the SAM database here, so you can decrypt that file. So actually, Windows, the volatility allows you to dump that section that I'm talking about. So what it's doing, this small plugin helps you to dump the hash in the memory or maybe in Hive file, doesn't matter, and it will show me the users and also the hash combination. So here, for example, we're looking at two users only. One is administrator. Of course, we are talking about domain administrator here, and it has 500. Here we have two bunch of characters. What are they stands for? Anybody knows that? Probably you guys should know that. NTLM, and what's the other one? LM, yes. Why do you think, guys, we have LM hash here?
Password is too short.
No. Sorry? Exactly, that's true. So actually, if you set up your Windows 2008, brand new, and create your domain brand new, you will not see any LM hash here.
Wait, I thought
But-
LM is on in the font instead of the back. Aren't those the same?
This is the NTLM. No, they're not the same.
The font one is the same for both administrator and guest. I thought that go for empty or something like that, and then NTLM is empty.
This is empty, probably. This is empty, but this is not. Actually, we're going to crack that password. Don't worry about that. So here's the thing. Great catch here. If you're upgrading your old domain controllers to a Windows 2008, and if you are coming from backward compatible domain controllers like support to the LAN management environment too, you will probably have LM hashes in your Active Directory too. If you migrated all your domain controllers, you should have to increase your first level to get rid of LM hashes. Otherwise, that means it's easily crackable here. So for example, if I copy this one, by the way, you can use the John the Ripper, but I will show that even Google will help you. Huh?
They stored hashes, rainbows.
Yeah, exactly. You can use rainbow tables or maybe the okay, right here. What is it? Super complex password here. Not that awesome. Right here. Password. I always use the complex password in my computers, as you can see now. Just try to keep this example as simple as possible. So in CTF, you will be asked that password and also the hash. So you will have to find out. Okay, so this is how we can do that. There's another way to dump the hashes. That's LSA dump. But this thing is a little bit different. It also dumps the data protection API keys too. If you guys are familiar with Windows crypto libraries, it used data protection API. It used a key that has been protected by system, which can be dumped by LSA. So, which means if I have the memory, I can use LSA dump to dump that encryption key to decrypt your memory or whatever you're encrypting. Okay, let's get rid of this one. But this one is good one, and I'm going to show this to you. Timeliner. So we have a lot of things in our hand here. So I need to see them in a chronological order, so I can better analyze this thing. So Timeliner stands for exactly for this purpose. It's going to create me an Excel file here. So the output is going to be the dump/timeline.excel, and the output format is going to be the Excel file, and the plugin name is Timeliner. Timeliner is going to analyze the memory, find all the events that happen, in this memory, and also put the time. But unfortunately, it's not going to be the ordered. So you have to order by yourself this Excel file. It will take some time to show up. Let's wait for that. But I'm going to show you guys another session, another items here. Oops, I copied a lot. Okay. So sessions, this is important. If you are taking a memory image, you need to know how many sessions you are working with, because this is a server. There might be multiple sessions, and you need to know which process belongs to which session. So for example, vmem, remember, we found them in session 1, and as you can see at the bottom of the screen, vmem belongs to session ID 1, which has 25 processes. And if you see that, it has also Wireshark here, okay, and also CMD here. But behind the scene, there are other processes going on with the system itself. So these are under responsibility. These are not under responsibility of user. Okay, if he is not an administrator, he can't do anything on this section. That's why you can separate the attack surface by looking at the ID of that. So, and also you can get the clipboard if anything in the clipboard. Let's say if you copied anything, it's pretty straightforward. Just use the clipboard. But I'm going to show you the screenshot here. It's one of my favorite. I always want to see the screen of an environment, so I can imagine what kind of process Windows exists. Of course, it's not going to show you the full definition of the environment, but it's going to give you some idea. By the way, remember we talked about this multiple sessions, and it's going to have multiple session IDs, and every session ID may have multiple sub-session itself. So that's why a default session, a disconnect session, and also winlogon session, those are different sessions in Windows environment. That's why this thing showing you multiple things here. But all you need is actually winlogon PNG file. So let's take a look at that file, how it does look like. So here, for example, session 0, desktop, of course, you will not see anything in session 0 because it doesn't have any desktop here. There's supposed to be something here. Oh, WinStat 0 default, sorry, it's not here. But let's analyze this window. So we have WinPimo 1.4 here, and it says in the address C/TMP WinPmem. What it should be? What do you think it is? It's Explorer window, right? The address right here is 3D here. So you can imagine. We have the command line here, and also the taskbar here, start here, running applications here. So you can see the other parts in Windows environments where user prompted, not something, and also the date here. So it just gives you some idea how the desktop look like. It's useful actually. I like it.
So I didn't understand. Is it like system takes screenshots?
No, it's actually creating from the memory. Every window have its location and also the name. Okay, it's just creating an ad hoc screenshot here.
Okay.
But it's good approximation. I really like it, and I saw for the first time. Okay, and Windows 3, it's really similar to process 3, but this time you're looking at the Windows 3, which window is the parent of another window. It's good to know because if you know which process is creating the other one, then you can reduce your attack surface. So for example, in incident response, you need to know who is responsible for this event, right? If the user is clicked on something, then you can blame the user. But if this is something causing from your vulnerable server, you need to know that as well. So if the parent process, so for example, is SVC host, then you can blame the user. If the parent process is Explorer, and we are talking about some ransomware here, probably you're going to blame your user. But you need to know by looking at the Windows tree of this environment. So let me find that if I can, because there will be a lot of things here. Okay, I think it's right here. So for example, here, Explorer exe here, some of the visible parts. But remember, these things, everything in Windows environment, it includes a lot of subframes. So that's why you are looking at tooltips, another shadow box fake window here, another tooltip. Those are actually different windows. Windows by itself, only one window includes a lot of windows itself too. So that's why. And here we have Explorer exe here, and it's supposed to be a CMD here. I can see that maybe it's in another section. Okay. Anyways, I couldn't find it. We need to take a close look at it, but I think we have limited time. Yeah. Anyways, let's take a look at this one where it's, ouch. We get an error here. Feel like a character string somewhere. Anyways, it's supposed to be an Excel file with a lot of columns, and maybe we still can see something in here. Now, that's the problem. Sometimes it just doesn't create anything. Okay, let's take a look at this one important thing in the memory file. So let's assume that we grab this memory and we need to find some malware, right? So here's the challenging part. And I'm going to analyze this memory file, which is belong to the Windows 2003 machine, and I will use find here. So this small script searches for the potential malware signatures, but it's potential. It doesn't mean that it's malware, but at least it's a good starting point. And it's going to show me, copy those sections to dump file, and also it's going to show me the small binary dump and also the assembly section of that. I like this screen, it's really good for, if you are doing this in your screen, it shows you really cool, huh? Remember, in your screen, remember, this is the movie screen, well, Okay, so let's go back to the real world and let's see what kind of stuff we hear. So a lot of process here, and of course I can analyze these files one by one. All I need is I need to get the executable files, right? Because those are the executable files that those are being identified as malicious is my guy. Okay, so how can I find that? If I say ls dump here, there are a lot of files. So how can I find whether this one is an executable or not?
We need to see properties.
Sorry?
Do we need to see properties?
Yeah, properties. How can I do that? There are more than 10. Remember, our rule is if there is something that we need to do more than 10 times, we have to automate that. Okay? We cannot do that manually. So what is the trick? How can I get the properties of all these files and also make sure that these are executable?
So write a script.
Let's write a script. Let's write a script. That's pretty easy. Remember, this small command allows me to find the type of an, so for example, process. Now, let me choose one here. So let me choose this one. Come on. Okay, if I hit enter, it says dbase iv something, right? This is the type of this file. I need executable. What's the signature of executable? Remember previous one, notepad executable, how does it look like? PE32, right? So I need to grab PE32. What I'm gonna do is find under dump file, dump, starts with process something, and I want you to grab PE32. Okay, this is going to, Sorry?
File.
File.
Ah,
Can't you just discuss the file altogether? Or just do it?
I'm just gonna grab PE34. There we go. So we have these are the potential malicious files. Those are executable, right? So I'm gonna take a look at which one is the malicious file, and also check for the signature, because these are potentials. So I need these files to check with some signatures. You can use Yara signatures, but unfortunately I couldn't make them run. That's why I'm going to use clam AV. Okay, I'm supposed to turn my Kala Linux on because it's on my Kala Linux. Okay, let's copy these files, these 4 files, to another directory. What is that? Command line. Let me get rid of these. Okay, I want to copy all these 5 files to process folder. How can I do that? For file in dollar this command. Okay, but remember, this is going to print this line, and what I'm going to do is I'm going to cut these lines with some delimiter. I need only this section. This is the file name, right? So I'm going to cut with slash and get the second part first, and then I'm going to cut with colon, and I'm going to get the first part. Everybody got this idea? Okay. So, and then copy this file, dollar file, actually it's under dump slash file, to my process dollar file, and then done. So it's not going to matter how many files, it will be right here. Okay, so I have my 5 files here, and I will copy them to my Kali box here. And let me get rid of these old files too, because I already tested before. Just want to make sure that everything is working correctly. You know, real-time demo is always difficult to do. So ClamAO is pretty simple. I don't know whether you guys used it before. This is an open source antivirus. It is signature based. It's not doing any heuristic analysis, and you know the fantastic job the other antiviruses does. But it has good signature base to analyze some of the files. It's pretty useful, and you can use that in a command line. It's really useful for command line junkies like me. So what I'm going to do is scan the folder under process. So actually, I'm going to put it at the end. I will say -I for, what was that? The help should supposed to say that. Yeah, infected. Show me only the infected files, and also bell if you find some infected things, and it's going to be under processes. Scan everything under processes. Okay, that's that easy. So it's going to search for its signature database on this piece of process memory sections. Then it's going to tell me which one actually is the problem. There we go. We have something here. Actually, it should bell also, but unfortunately, I connected with HDMI. That's sound went to there. Okay, so these 2 things, it's telling me that there is a meterperator session here. You know, it's my favorite, right? So meterperator, remember, process at this address location and at this address location. Actually, it's the same thing. The difference is ending point. Okay, so we have a meterperator in our machine. That's where we need to look at it. Okay, this is how we can use volatility to find some malicious executable in memory, and you know, combine it with clam AV. Okay, so by the way, I forget to again copy this thing to a file, but you're supposed to see the so that address section right here, it's exactly the same thing. So by looking at this section, you will get the process ID. So you can know which process is being infected by a meterperator. So actually, it's a little bit long list here, but if I scroll up here, maybe I can quickly find it out. Why don't I just search that? let me copy this and search this. Ouch! There are a lot. I need to find the endpoint here. I think it's supposed to be this one. Okay, there we go. So at this point, we're looking at PID 888, and it is, as we see, host exe. Who is responsible from the attack? Admin or user? Admin, that's right. So this is a little bit, requires a little bit more investigation. Why we are infected? What kind of communication this process have with other machines? So we will take a look at that. But let's just quickly get that very quick, and then we can finish that. Actually, I think this week we're not gonna get any pizza. Sorry about that, but it sometimes happens. Okay, what I'm gonna do is use the same thing, and this time I'm gonna use sockets, whatever it was that, the network thing. Conscan, let's use conscan. There we go. So this is going to be the end of our conversation. So the process 888 has a connection with this is its IP address, I think. Yes, this is its IP address. The local port is 1180, and the destination IP is 1.101 and port 4444. Do you remember 444 port? 44. That's the famous port. And by the way, what is that IP address? 1.0.1.101. Let's take a look at our topology here, and it's going to give you an idea. Okay, so this is 1.0.1.101, and there is a multiprocessor session between these two. How is this possible? Probably our attacker compromised this machine first and exploited something on this one to grab the connection with that, to get the multiprocessor session. This is the, our approximation. Of course, only the small percent of the attack vector. You need to find what kind of vulnerability is being exploited, when it happened, what kind of attack vectors is being used, whether the domain controller is being compromised or not, things like that. You have to find that answer, and you have to show me some kind of attack vector. This week, I will stop right here. I'm going to get some questions now, and then don't forget that, okay? Yes?